Already we have learned the elastic collision in one dimension, so let's read out about the elastic collision in two dimensions. It's a very important chapter for your boards as well as IIT examinations. So at first, let us take two bodies A and B whose masses are m1 and m2, and A is moving with velocity u1 and m2 is moving with velocity u2, where u1 is greater than u2, such that there gets the collision over certain point. Let us make both the objects move in the x direction before they gets collided. Then after the collision, let the body of A, which is mass m1, make an angle theta with the incident direction x-axis with an angle theta, and m2 it goes with an angle phi. Now we can see here that with velocity v1 and velocity v2, here the body A has the two components, that is one horizontal component and one is vertical component. Horizontal component, it becomes v1 cos theta and this becomes v1 sin theta. Similarly, for the body B, the horizontal component becomes v2 cos phi and this is minus v2 sin phi. Since the collision is perfectly elastic, therefore the kinetic energy must be conserved. So we can have this formula: half m1 u1 square plus half m2 u2 square equals to half m1 v1 square plus half m2 v2 square. Let it be this equation 1. Again, applying law of conservation of momentum, okay, which is also a vector quantity. If you go with the x component, we get m1 u1 plus m2 u2 equals to m1 v1 cos theta plus m2 v2 cos phi. Also, if you take the vertical component, before the collision the vertical component was 0 here, momentum, and here it is v1 sin theta minus v2 sin phi, considering the direction upward. Now we will have the two cases. The very special one case is, let the body of mass be m1 be equals to m2 equals to m, and let the body be at rest, that is u2 equals to 0. Putting the values of this, here u2 equals to 0 and here u2 equals to 0, and putting the value m1 equals to m2, the equation 1, 2 and 3 will become. So putting the value m1 equals to m2 equals to m and u2 equals to 0, we get equation 3, 4 and 5, and finally we get the results of